So what we're going to talk now are some of the wireless local area networks, the Cisco wireless architectures, and the ability to, again, what we're trying to do is expand our wired network with these things. The wireless architectures or the wireless devices that we have, the autonomous access point. The autonomous access point is what you have and what I have, where we go to with a web interface and we make the configuration changes to the device. We can go in and, change the password, whatever other modifications that we want with it. That's going to be an autonomous access point. And autonomous access point connecting to the device itself. And yeah, I know it's cached. The spectrum we go here, we're going to go in and make whatever configuration changes that we need to or want to make with this thing. The wireless, whatever we want to do with it, internet connectivity. We've looked at some of these things, the router settings that we're going to do. We got to go in and do them one at a time. DHCP, whatever we're going to do, one at a time. Not necessarily the way we want to do things, but we're going to have their cloud-based AP architecture. This is the Cisco Meraki wireless devices are managed from the cloud. We had managed, but we didn't use lightweight access points, but we had a management software that we were able to manage all of the devices remotely. We didn't have that many, but we could do that. Cloud-based allows us to manage a whole lot of devices in a whole lot of different locations. Back to we're trying to minimize the number of individuals that we got to send a paycheck to every 2 weeks or whatever. But we want somebody that knows how fewer people, but better trained in order to be able to do this thing. So instead of having to have somebody to manage wireless at each of our physical locations, cloud-based, hey, I can have an individual sitting in, let's say Denver, and they can manage everything in Denver and Colorado Springs and Dallas and Jacksonville. Split MAC architectures, and we'll look at some of these things as we go through. And then LAN controller deployments are the things that we want to look at as we go through here. The wireless LAN components are going to be the clients, the clients and the devices that want something. The access points are going to be the servers. They're going to service up a connection that we have here. And then we have this other thing over here, the WLC, the wireless LAN controller. The wireless LAN controller is going to be the device that we're going to connect to, and we'll do a lab this afternoon that we're going to connect to and put all of our configuration settings into the wireless LAN controller. Once we've done that, the wireless LAN controller is going to send those configurations to the laps here, the lightweight access points. The lightweight access points are going to connect back and forth from the wireless LAN controller. We have the clients here. We can have the multiple SSIDs and the VLANs here. So we're going to connect these things with trunk ports so that we can have multiple VLANs. And we're going to have a trunk port here. And this is actually showing an aggregation, a link aggregation. So it's going to be, it doesn't have to be, an ether channel. Either an LACP or a PAGP. Try to keep some of these terms coming back. Recall, so an ether channel putting together higher speed. And if you think about it, yeah, that kind of makes sense. Just like when we talked about for the trunk ports, it would make sense because we have different access points connecting to the switch, and then all of the signaling gets consolidated on a single link to the wireless LAN controller. Wireless LAN controller is going to be pretty busy. Access ports and trunk ports, when we assign the wireless LAN to the components to the VLANs. And you can try these things out and see if they work, but when you have the multiple SSIDs mapped to the multiple VLANs, you got to have trunk ports in order to allow all of the different VLANs to communicate on it. link aggregation groups if we need them. And again, why would we want them? Because we got the communication from all of our different access points, in this case lightweight access points, that are then going to be sending information to the wireless LAN controller. The access points that we have here, the things that we have, the primary functions is to bridge the wireless data to a wired network. Yeah. And I think we said that multiple times this morning. We have this ability over here, and in this image over here we have WLAN 100 and WLAN 200, the SSIDs, and they're going to be mapped to the trunk for VLANs 10, 100, and 200 as we go on here. The trunk links 10, 100, and 200. The management IP, and this is going to be the management VLAN. We're going to have a management VLAN, and then that's going to be the 10, and then we're going to have 100 and 200. These guys are going to map the SSID to the VLAN, so that we are now going to send VLAN traffic over our trunk. The primary function is to bridge the wireless data to the access point, to bridge the wireless data to the wired data. We still want to have the isolation that we talked about when we did VLANs. Accepts connections from a bunch of wireless clients that are going to get there, become a part of the local area network, and we have a central point of access for these things. Autonomous, self-contained. Autonomous is what we have. Autonomous is what all these guys are. This is autonomous access points. That means that we have 1, 2, 3, 4 of them here. We're going to have to go to 4 of these things and configure each of them. That is autonomous. You know, they are not dependent on anything else. We have wired and wireless hardware to make them work, and we can offer one or more basic service sets. And then this one over here, we're going to offer 2 of them. One of the SSIDs, the basic service sets, multiple basic service sets. Remember, the basic service set is basically a MAC address, which is going to be associated with an SSID that we're now going to offer to the wireless clients, SSIDs 100 and 200, and then whatever we're authorized to log on to, pre-shared key, we'll use that particular one. If it's a radius server, whatever we're mapped to use, we're going to get those things. And then the SSID that we connect through our wireless device is now going to be associated with or mapped to a extension of the switch networks, connects the SSIDs to the VLANs. And that's what we're trying to do, extend the network for all of our users. The architectures that we can have are autonomous access points and lightweight access points. Autonomous handles the access security, overall operation, no separate controller for it. The lightweight access point uses a wireless LAN controller. Limited firmware functionality, it just does the work. All the quote intelligence unquote is going to be on the wireless. Wireless access points in an access layer, a 3-tier or collapsed. The wireless LAN controller is going to be at the distribution or the core layer. So the access points themselves are going to be where we connect, where we get the information from, and that's where the access points are going to be. The quote intelligence unquote is going to be someplace else. The wireless LAN controller is going to be at the distribution layer or at the core layer of these things. The Cisco, we have autonomous access points, the Cisco Mobility and the Cisco AeroNets, and then we have lightweight access points, part of the unified wireless network or the unified wireless configuration. So again, in these, the autonomous, we configure the autonomous. It's a standalone wireless access point. The lightweight access points going to be centrally managed, centrally configured by a wireless LAN controller. You can't get into them and configure them once you upgrade to, and interestingly enough, you upgrade an autonomous wireless access point to a lightweight access point. Then you need a wireless LAN controller in order to be able to configure those devices. Autonomous, I think I've probably already beaten it to death. The access layer is extended by the access points, and that was the whole thing that we're going to do, and we have to map these things. And then this one, the SSIDs, we have to individually, for each of these devices, configure the SSIDs and then map them to trunk to the distribution up here. Each of them is going to be eventually trunked to trunk ports because we have multiple VLANs. In order for that to happen, we're going to have a trunk port to put the multiple VLANs on it to send the data from one to the other. Short path for data, and that's what we're looking for, is the short path for the data. Travel between the wireless and the wired. The wireless only go to the access point to connect to each other or the wired network, not part of the data VLAN when we do these things. We need a dedicated management VLAN for these, and we do have a dedicated management VLAN that allows them to go. Single access point to the network, and then the wireless users only go to the access point to connect to these devices. Management IP for these, and then this is again not part of the data VLAN. Each of the access points, we need a management platform. Management platform is just simply going to be a machine that is connecting to the devices that will allow us to do. That's the image that I was looking for earlier. You see, this guy in here is on channel 9, right in the middle of things, and this is expand the frequency range here from a 20 meg to a 40 meg to go from 5 to 13. Everybody else here with 1, 6, and then wherever he should be someplace else. But you can see, and if we had this one back here, you could see, or you can see from the 6 that he's interfering with the 6. Far enough away that it's really not affecting me because of the signal strengths I've overcome. And this shows the wireless access point and the repeater. This is a D-Link repeater that's down here. The signal strength, and these obviously were taken from in the neighborhood of the wireless access point. But each of them are operating in here and sharing that information. Let me get rid of this one. And we'll go back to where we were. The autonomous access point acts as the network scales. The management becomes more cumbersome. And, 4, not too bad. 5, okay, I can probably do that. 15, it's going to become a little bit more difficult. If I get 40 or 50 of them, then I'm in a situation that I probably want to have a little bit of help. In this case, management becomes more cumbersome. The same SSIDs on multiple access points. We need to allow roaming for these things and extend the VLANs to the access points so that the users keep their IPs, and that's what roaming does, where it passes the connection off from one to the other. Same SSIDs on multiple VLANs, and when we do that, when we're going to go to the 20 or 30 or 10 or even 15 of these devices and configure the same thing on each of the devices, this is where automation comes in. Automation is designed to make repetitive tasks, we would say that, but we extend the VLANs to the access point so that the users keep the IPs, the SSIDs and the VLANs extend at layer 2, and layer 2 is going to again be at the wireless definition. The VLANs are routed at the distribution layer. We got the access layer. Distribution layer is designed to route these things, and the core layer is just designed to do high-speed switching. Back to the things that we talked about last week in the 3-layer architecture, or the 2-layer with the compressed core distribution layer. VLAN routed at the distribution layer to the access switches themselves. The cloud-based is the Cisco Meraki architecture when we do that. Autonomous access points, difficult to manage. could install, purchase and install a management platform. And there are a number of management platforms that you can get if you want to. The Meraki is cloud-based, centralized management, configuration and monitoring of the access points, can be deployed automatically once they're registered. Cisco comes with certificates, and the lightweight access points are going to have certificates that identify themselves as a Cisco authorized device. They can automatically join the network and get their configurations when we do these things. The access point contacts the cloud when it's powered on and gets its configuration, does a self-configuration. And these are all autonomous access points. They're just managed centrally. They're not managed as an entity, I guess we would say. But autonomous access points managed centrally for these things. The architecture for these things, the cloud-based Meraki here, we have the Meraki cloud that then is going to be able to connect to the devices and manage the autonomous access points that we have. Control plane, and we're introducing a couple of things here, control plane and data plane. The control plane is when the management, we're going to have three planes here when we get to automation. We're going to have the management plane, the control plane, and the data plane. The management plane's us. That's where we connect to the device and make the changes wherever we are. The control plane are the changes that we make, and maybe be where the routing tables are. The data plane is where the work gets done, where the data gets forwarded, where the data gets shipped. Data shipping is going to happen at the data plane. End user traffic passes through the access point at the data plane, and that's going to be an important concept when we get to the wireless LAN controller here in just a few slides. Actually, right now, the split architecture for what we have is the autonomous access points. The RF management may be difficult. We got to select and configure a channel, detect and deal with rogue access points, manage the power levels, manage the security, and each access point is going to have its own security. To do these things, no convenient management point. We have IPSs, intrusion prevention systems, QoS, quality of service, and bandwidth policing may be going on here. And we have shifted functions to a central location in the split architecture, the split MAC architecture. The configuration of the individual devices doesn't happen at the individual devices. The work still takes place at the individual devices, but in these autonomous access points, all of those things have to happen. We have to configure them one at a time. All of these things have to happen on the split MAC architecture, but instead of doing them one at a time, we're going to manage them all centrally from a wireless LAN controller. Couple of things that happen here. We have the autonomous, let me see if I can scroll on some of these a little bit. The autonomous over here, we got that. We own those. That's what we have, what I have in my house, what you probably have in your house. But over here we have the lightweight access point. And we have the lightweight access point down here. We have the wireless LAN controller up here. We got a switch in here. We got this thing called CapWAP. The CapWAP, it's going to be the control of the wireless access points. Autonomous versus lightweight access point. The management functions, RF management, where we're going to set the power of the access points, where we're going to pick the channels, maybe the access points. They're actually going to automatically pick their own channels. Association and roaming management. We'll configure roaming. Client authentication. What kind of authentication are we going to use? WPA, WPA2. What's going to be the pre-shared key? What kind of security management? What kind of quality of service are we going to do? That's then going to get sent to the lightweight access point through the CapWAP tunnel to the lightweight access, where it's going to handle the real-time functions, the transmit and receive, MAC management, encryption are all going to take place here. So real-time are going to be on the device itself, and let's just call it data shipping. And up here, the management is going to take place on the wireless LAN controller. a lot more efficient way to do this. The CapWAP tunnel here can be connected to multiple devices, not just one. We could have this, we could have 100 of these devices connected here and manage them all centrally. So if we've got that 10 or 20 or 30, maybe we want to go into a situation like this so that we can centrally manage them from the wireless LAN controller and send the configuration information to them. This was probably one of the first automations that we had in Cisco. And this wireless LAN controller has been around for a long time. So what happens on these things, the wireless LAN controller and the access points. The lightweight access points are configured with an authentication certificate built in, a Cisco certificate. So when they get started on a network with a wireless LAN controller, they're going to send a discovery request. They're trying to discover a wireless LAN controller. And the wireless LAN controller sends a discovery response. Yes, you're here. You've got a valid authentication, a valid certificate. So then the access point's going to request to join the wireless LAN controller network, and then the join response is going to accept it. So even starting these things up, you don't really have to do anything except put them on the network. Once you put them on the network, they're going to automatically join the management situation or the management function here, and we'll see that when we do the lab a little bit later to do these things. So a discovery request, automatically join. Now I can send the configuration information to this access point. I don't have to go to it. I don't have to connect to it. It's already configured on the wireless LAN controller so that we have a whole lot more automation when we do these things. Autonomous versus the lightweights, the real-time 802.11, and this is the configuration that we're going to work on a little bit later. We're going to have a router on a stick to do these things, to route between our VLANs. We got the wireless LAN controller, trunk ports to enable to communicate with it, trunk ports in order to allow the traffic to go from one to the other. The real-time process here for the 802.11, the sending and receiving of the frames, and then the beacons and the probe messages are all going to be going on the devices. Got to interact with the clients at a low level, the MAC addressing. Stay with the AP, the hardware that's closest to the client, the one that's got the strongest signal, characteristic of wireless. Will do that. The management frames are not integral to the RF frames. The RF frames are where we're going to be sending the data. That's where the data shipping is going to be. The management frames that we have up here that we're going to do the management with by configuring the SSIDs, configuring the security. That's not part of the RF. The authenticating using the proper password would be, or the proper pre-shared key would be, but the management itself is going to be done on the wireless LAN controller. So we're going to move those functions to the central platform, and then we're going to divide the functions. The hardware is called a lightweight access point, and it's going to perform the real time. We're going to connect to it. It's going to do the encryption. It's going to send the information off of the access point, the physical connectivity. This is the split MAC that we talked about. The code image and the local intelligence are removed. We cannot do any of the configuration. We can't set the security on this. We can't change the channel on this. All of that's got to be done from the wireless LAN controller. The management functions are performed on the LAN controller, and the access points boot and bind themselves to the wireless LAN controller. This is back to the process that we talked about with the CapWAP tunnel, that they would identify themselves or authenticate themselves with a pre-installed certificate that authenticates them as a Cisco device. I wanted to say Microsoft, as a Cisco device. So it becomes valid, and allows connection, and then all of the joining process will all happen automatically with these things. And CAP/WAP, control and provisioning of wireless access points. You'd think I could remember that, but the CAP/WAP process, control and provisioning of wireless access points. The AP, just like we saw a little bit earlier, sends the discovery. The DH, and this is to get an IP address, because in order to communicate, we've got to be able to have an IP address. So first it's going to get from the DHCP server the DORA process, discover, offer, request, and acknowledge. We haven't done DHCP yet, but that's going to be the process that we'll use. After it gets an IP address on the network, the wired network that we've configured is going to send a discovery request to the controller here that will then send a discovery response. The DTLS connect it's going to identify transport layer security. It's going to identify itself and send a join request, and then we get the join response. The image data, the configuration status request, and then the configuration information gets to it. Change state event request and any change states, and then we're going to get the keep alive to be sure that we're still connected to these things. Configuration update request, configuration update response, if there are any of those things that are going to go on with it. The CAP/WAP, control and provisioning of wireless access points. The same thing that we just saw when we go through the process here. The AP boots up, and we do a wireless LAN controller discovery. It's going to look for one of these things. The AP and wireless LAN controller CAP/WAP tunnel is going to be the tunnel itself. We got two tunnels over here. One is for control and one's for data. The control tunnel is going to be secure. It's going to be encrypted. The data tunnel isn't unless we do some other configurations with it. The tunnel is created. The access point's going to join. It gets the image request and response, configuration request and response, and then it's going to be up and running. The text over here, the CAP/WAP control messages, carries exchanges that are used to configure the access point and manage its operation. The control messages are authenticated and encrypted so that the access point is securely controlled by only the appropriate wireless LAN controller, then transported over the control tunnel. The data itself is used for the packets traveling to and from the wireless clients associated with the access point. The data packets are transported over the data tunnel but are not encrypted by default. Data encryption is enabled for the AP. The packets are protected by the datagram transport layer security, the DTLS, datagram. So we can configure encryption for the data, but it's not there by default. The control is going to be by default. These tunnels are negotiated by the devices without any input. So the tunneling protocols between the access point and wireless LAN control, and then the RFCs that would be associated with it. Every wireless LAN controller and lightweight access point got to authenticate. Digital certificate is pre-installed on the devices. The devices authenticate before becoming part of the network, and it allows the access point and the wireless LAN controller to be physically separated. And that's what we're going for here, the central management of these things. And this shows VLAN 100 and VLAN 200 for these things, the CAP/WAP tunnel, the management that goes on, SSID 200 and 100, and they're going to be mapped to those two particular VLANs. The management IP here is going to be the 10.10.10.10 IP. The 10 network would be breaks the layer 2 dependence, and VLAN 100 exists at the wireless LAN controller and at the lightweight access point as SSID 100. This is again mapping the VLANs or the SSIDs to the VLANs to SSIDs, whichever way you want to think about it. But we're going to, when we connect to an SSID, we're going to put ourselves onto a particular VLAN. Tunnel between the IP the tunnel between the IP addresses, the management VLAN. We're going to have a management VLAN. We're always going to have a management VLAN. As the network grows, it's going to build more cap-wap tunnels to do this thing. And this shows them just around. They're going to go through the switch. The tunnels are going to go through the switch here. So we have multiple SSIDs, multiple access points, and each of them has SSID 100 and 200 on it, so that we can now have multiple locations where we can access the SSIDs, and by accessing the SSIDs, get onto the VLANs that we should be on to be able to use the resources that we need in order to do the wireless LAN controller functions here, performed instead of at the lightweight access point. Dynamic channel assignment, transmit power optimization, self-healing wireless coverage, flexible client, dynamic client load balancing. So that if we get too many people connected to one, we're going to shift some of them to the others, shift some of them from one to the other. RF monitoring that's going to go on here, security management, wireless intrusion protection system. So all of the configuration is going to happen at the wireless LAN controller. The quote intelligence unquote is going to be at that. The different methods or different ways that we can have, or the different things that we can have with these, and I messed myself up here. We have the unified wireless LAN controller, just an individual wireless LAN controller right here that we would have right place with these things. The lightweight access points are down here showing this little guy going across. Roaming is enabled. We can roam from one to the other. The wireless LAN controller is going to manage the what goes on with these things. It's going to allow us to continue to have the same IP address as we go from one to the other, because we're going to be on the same VLAN. It's just going to shift it from one to the other. The cloud wireless LAN controller, and this is just kind of a series of images of where is it going to be. This is going to be a cloud wireless LAN controller, and if you look in the notes, the wireless LAN controller exists as a virtual machine, supports up to 3,000 access points. So when we go to this one can support up to 6,000 access points. When we talk about, managing wireless and we've got 4 or 5 devices, are we going to go buy this? Probably not. If we've got 100, are we going to go buy this? Probably so, in order to do that. The embedded here is embedded in the switches themselves, and it's going to support up to 200 access points. And then the Mobility Express down here is going to support up to 100 access points. The cap-wap is formed between the wireless LAN controller and the AP host. So in these, the deployment model, unified cloud, embedded, Mobility Express, or autonomous. Which are we going to do? The wireless LAN controller, the central, the DC access, or other that we work on these things, the number of access points that are supported, the number of clients are supported, and that's a tremendous number of clients. And I think when you look at these things, we have 200 APs and 4,000 clients. It's about 20 per. 100 and 2,000 is about 20 per. The 3,000, now it's a little bit more. That's what, 60,000, 32,000. So it's about 10 per in the private. And then we get about 10 per when we do these things. I just as how many can be connected to each access point. 20 to 30 is a typical number that I think you're going to hear. Access point modes. And this is, we have the lightweight, we have a local mode, REAP mode, bridge mode, SE Connect. We're going to look at these things in a little bit more detail. Sniffer mode, road detector mode, and monitor mode. In the autonomous, we can have root bridge, non-root bridge, work group bridge. All this bridge business should stand. Scanner mode, spectrum mode, or repeater mode. So what can we configure with these? This is more than I certainly can with mine at home, probably certainly more than you can with yours at home, but a number of different modes available to these things. The The modes here, and again, let me just click these open because I got a little bit more verbiage here for each of these. Local, one or more functioning BSS on a specific channel. Monitor, receivers enabled to act as a dedicated sensor. Flex Connect, as a remote site, can locally switch traffic between an SSID and a VLAN. Sniffer captures traffic. A rogue detector to detecting rogue devices. A bridge, a dedicated bridge, point-to-point. Flex Bridge, Flex Connect operation enabled on a mesh AP, and then the SE Connect dedicates its radios to spectrum analysis on our other wireless channels. What else is available there? I said a little bit more information on some of these things. The default lightweight mode offers one or more functioning basic service sets on a separate channel. It's not transmitting. The AP is going to scan the other channels to measure the noise level and measure any interferences that's going to go on with these things. Discover rogue devices and match it against the intrusion detection system events. The monitor, the AP is not going to transmit. It's going to be enabled to act as a dedicated sensor. Checks the IDS events, detects rogue access points, and determines the position of the stations. And this is going to be based upon the signal strength, so that it can kind of locate what goes on by overlapping signals that the devices. So it's going to have a direction, and a signal strength, which will allow it to actually estimate the position. The Flex Connect, an access point, a remote site, locally switch traffic between an SSID and a VLAN if its CapWAP tunnel to the wireless LAN controller is down and it's configured to do so. And we'll do that configuration, look at that configuration in the wireless LAN controller. Sniffer, an AP dedicates its radios to receiving 802.11 traffic from other sources. Our packet capture device, the traffic's forwarded to a PC running the sniffer, running a Wireshark, so that we can see what's going on the network. And other sniffers there, Wild Packets, OmniSeek, or Wireshark. Wireshark, again, if you haven't, I would recommend that you do it. Run it on your own network. Other people kind of get upset when you run it on their network sometimes. Other modes: rogue detector to detecting rogue devices. Somebody has put a device on our network that doesn't belong, trying to get us to connect to it in order to do, one of those kind of man-in-the-middle attacks, so that we'll send our information through their device instead of our bridge. Dedicated bridge, point-to-point connection, point-to-multipoint between two networks. Two access points in a bridge mode can be used to link two locations. So it's dependent on the antenna, the power level that we have. How far can we go? We're linking two different networks together, the outdoor mesh that we looked at. Typically, we're going to be linking two wired networks together. Flex plus the bridge, the Flex Connect operations enabled on a mesh. The SC Connect, the AP dedicates its radios to spectrum analysis on all the wireless channels, and we remotely connect the PC running to some sort of an analysis with this thing. MetaGeek Channelizer, Cisco Spectrum Expert. Spectrum analyzers are not inexpensive pieces of equipment. I think if MetaGeek, if they still have it, they used to have a USB dongle that you could put in that you could do analysis with their software, only on the 2.4 gig range. What you're usually going to get for a spectrum analysis is you're going to look at the entire. What we're typically interested in is the 2.4 gig or the 5 gig range. What's going on? What kind of interferences might we have with them? Other wireless components, the wireless LAN controllers, are going to manage the lightweight access points. That can be hardware devices or software devices, controllers, depending on how they're going to be configured. Access trunk ports on the access points operate in the same way as they do in the wired VLANs, and then the link aggregations configure link aggregation groups, combined controller ports. Ether channel is really what we're talking about when we talk about those, and only one link aggregation group is supported on each wireless LAN controller. We're actually going to have a limited number of ports that are available. The one we're going to use is going to have 4 ports on it when we do it.